Welcome to the extra invited talk at noon after Jan Orlari's keynote at the International Faust Conference. Due to a communications mix-up, this has been recorded later and submitted as a video after the conference. It's about Faust on the Analog Devices SHARC module. I'm presenting this along with Pat Scandalis, who has done most of the work integrating Faust into the SHARC audio module. So many of us know about the OWL pedal. So the OWL pedal is a great thing for getting your software into some hardware, your own Stompbox. There's the OWL pedal, and there's also the OWL modular. So it's a, I think it's a Reverb module that you can plug into your modular synthesizer. So this will give you an ARM for running Faust software, and you can change it, do whatever you want. It's a nice free open source software environment, and I believe OWL was started by a Kickstarter project. So what I'm talking about today then, though, is the new hardware by Analog Devices. So the SHARC chip's been around. So if you know about floating point signal processing chips, you know about the SHARC. Universal Audio uses it. It's a nice, powerful floating point DSP chip. And so there's this new module, which is a little circuit board that contains two DSP cores. So it's like two SHARC cores and an ARM chip all on one chip. And so that's what's called the SHARC audio module, developed by Analog Devices, ADI. And so it's the new version, the so-called Griffin part, which is the SHARC SC589, two DSP cores and one ARM core. So this is a very nice hardware platform for developing things. And so to support this for Faust, there's a new Faust to SAM script, and it's already there. If you do a git pull, then you have it under examples. So what I'll do now is let Pat give you an overview.
Hi, I'm Pat Scandalis, and I'm going to give an overview of the tools for running Faust code on Analog Devices' SHARC audio module board. We'll look briefly at the SHARC audio module. Then we'll look at the Faust to SAM command. We'll look at the ADI toolchain, and finally we'll look at some examples. This is the SHARC audio module. Here we have the Griffin part, which is a dual-core SHARC chip. And there's various types of I/O, most notably line in and line out. And then here we have the ICE 2000 or in-circuit emulator, which is used to send code directly to the cores in the SHARC from CCES, which is the cross-core embedded studio that Analog Devices provides for developing code for this. On the flip side, we have the DIY card, and it provides a number of different types of important I/O. We have quarter-inch audio stereo in and out. We have conventional MIDI DIN in, out, and through, and there are a number of switches which are mapped to MIDI continuous controllers, and there's a couple pots which are also mapped to MIDI continuous controllers. The Faust to SAM command is a part of the Faust installation and is used to convert your Faust algorithm into 3 C++ files that can be dropped into Analog Devices' bare metal framework for the SAM board. Alternatively, you can use the Faust online editor to generate these 3 C++ files. Drag the DSP file into the drop zone for the editor. You can try the algorithm with the play button. Reverb. The export button with the SAM drop-down option is used to export the 3 C++ files for the SHARC audio module. Let's take a quick look at the Faust installation. In the Faust installation, you'll find a directory called examples. And then within examples, you'll find a directory called SAM, which contains a number of different examples that can be run on the SHARC audio module. Here's a document that describes how to use the Faust to SAM tool to integrate with the SHARC audio module. Also, if you go to wiki.analog.com, there's a wiki page about Faust integration. If you go here and you search on Faust, you'll find an entry for Faust integration with the SHARC audio module. And if you take a look at that, there's some very good documentation here provided by Analog Devices, which is based on the document that is in the Faust installation. However, there's additional information like where to get the bare metal framework to use with the Analog Devices toolchain. Let's look briefly at a few of the examples that are in the Faust installation under Examples, SAM. So there are a number of different individual effects processing units, things like chorus, echo, flanger, reverb. There's also a full effects chain which includes all four of these effects. And the biggest example in here is the one entitled Virtual Analog, which is a full monophonic 70s style virtual analog synthesizer. Let's take a look at a couple other things that can be found in the virtual analog example directory. There is a TouchOSC interface which can be used to use TouchOSC as a MIDI controller to control the virtual analog synthesizer. Also, all the MIDI mappings are provided in a spreadsheet, very detailed set of MIDI mappings. Virtual Analog for Browser is intended to be run in the Faust Online Editor. It's just the Virtual Analog Synthesizer. And Virtual Analog with Effects for Browser is the Virtual Analog Synthesizer and the effects chain, and it's intended to be run in a browser in the Faust Online Editor. The tool chain provided by Analog Devices for compiling code onto the SHARC audio module is called CCES. If you go to Google and search on CCES Analog Devices, you'll be able to find a reference to the CCES toolset. Here is CCES with the SAM bare metal framework project loaded. You'll see that there are actually three different sub-projects for each of the cores. The first core is the ARM, and this is the SHARC Core 1 and SHARC Core 2. If you take a look here in the source directory, there's a subdirectory called Faust, and you see that in this Faust directory are the three C++ files that come out of the Faust to SAM tool. So this is Core 1, and if I look down here in Core 2, I also see that there are three files here. These three files in this particular case happen to be the virtual analog synthesizer running on Core 1, and these three files down here are the full effects chain running on Core 2. And it's booting up to a flanger, so it's a Stompbox. The buttons and the knobs are wired up, and I'll show that in just a second, but I'm going to play it dry first for just a second. And now I'm going to turn on the flanger. We had the Echo Box here running as a standalone bootable Stompbox, and I'll just play it for a second. So here we have the bootable chorus Stompbox, and I'll just play it dry at first so you can hear what it sounds like. And I'll go ahead and switch it on. That's a big sound. This is the reverb. It's free reverb. It's a Schroeder reverb. It's a very nice reverb. I'll play it dry first. And now I'll turn it on. And let's turn up the dampening a bit. Here's the full effects chain. Each one of the buttons corresponds to a different effect. This is reverb, this is chorus, this is flange, and this is echo. And I'll just play one chord so you can hear each of these. This is dry. This is with the reverb. This is with the chorus. This is with the flanger. And this is with the echo. This is dual core processing. The synth is running on core number 1 and the effects on core number 2. So here we have some reverb. Here we have some chorus. And here we have some flange. Here is a SHARC audio module with a DIY board. It's not connected to an emulator. It's only connected to power, audio in, audio out, and then there's a MIDI connection. It's set up to boot to the virtual analog synthesizer. So we're going to go power it up here, and I'll just play a couple notes. All 70 of the synth's controls can be controlled by MIDI. For example, here is the filter cutoff frequency being controlled from MIDI. There's also a TouchOSC interface which implements the full Minimoog front panel as well as a keyboard. This will run on an iOS device or an Android device, and you can play it from the keyboard. You can control any of the 70 or so controls that are in the model. And I'm going to go ahead and do a little noodling with the filter here. Bring up the emphasis a bit, the contour a bit. Classic analog filter. And now I'll switch to page number 2, and these are the controls for the effects which are running on core number 2, and I'm just going to play with the rate of the chorus. That's a nice sound there. So MIDI is going to both core number 1 and core number 2.